Hello, good morning. My name is Richard Taylor. It's my pleasure to present to you today on the subject of decarbonisation and circular economy. I'm going to discuss how these two concepts relate to bitumen and asphalt pavements, and then I'm going to go on to share a couple of recent examples from Shell of how we've applied this thinking to new offers. Before we start, I'll just pause for a second to take a look at the disclaimer. And I'd also draw your attention to the fact that this is a Shell presentation and that the organisers of the E&E Congress are not responsible for the content. So I'm going to start the presentation by talking about ways to reduce the carbon footprint of an asphalt pavement or decarbonisation. Most organisations, governments, companies around the world have made commitments to reducing greenhouse gas emissions and to aid with the climate action. On the right hand side, we can see the UN Sustainable Development Goal number 13. For the asphalt world, a lot of the levers here have already been identified and are well understood. So what's on the screen here is some quite simple modelling that we carried out internally within Shell. You can see the assumptions there on the right hand side of the slide. If we look at an end-to-end square metre of asphalt pavement, we can see that three areas really contribute most to the carbon footprint of that pavement. We have the energy and the carbon embodied in the bitumen itself. We have the fuel at the asphalt plant burner, and we have the construction of the transport of the raw materials, rather, that are coming into the plant and the finished materials coming out of the plant. So in this particular example, and it will vary from case to case, the transport of the raw materials and finished products makes up the major proportion of the footprint. The asphalt burner and the bitumen are broadly equal. So what we're showing here is if we make a change, and this is the extent to which we would see this example have a lower carbon footprint. And so if we start from the right-hand side, we would see that switching the pavers, switching the rollers, the construction equipment at the pavement side would make a measurable but relatively modest impact on an end-to-end square metre of pavement. Removing the CO2 from the aggregates would also have a modest but measurable effect. We all know well the impact of warm mix asphalt. Depending on the temperature reduction that you achieve, you may get as high as 10% maybe reduction in the pavement, and so on. If we were to remove the carbon from the bitumen itself, we may see a 20% reduction. Switching fuels at the burner or removing the greenhouse gas fossil fuel from the burner, switch to biogas or biodiesel, bioelectricity, would also see a significant decarbonisation. I'm not going to spend too much more in the presentation talking about this because, as it says, I think that this is fairly well understood, although it's still a significant challenge to decarbonise an asphalt pavement. But the main levers there are already known to us. Switching views, circular economy, what's on the screen here for those that are not familiar is something that's known as the butterfly diagram. And what we have on the left-hand side is the biosphere or the bio world. And on the right-hand side, we have finite materials. Sometimes people will refer to this as technical materials. And in both cases, there is a systematic view of circularity, and the circularity is a much used word now, and I think it's going to get used more in the future. But basically, on the bio side of the circular economy, what we're talking about here is regenerating natural systems. It's around making sure that the world is governed essentially by natural cycles and making sure that those natural cycles are observed and not disrupted. On the right-hand side, in the finite material space, what we see are these sort of concentric rings where we have a number of loops, as they would be described in the circular economy. We have a number of loops, and that the intent here is to keep the material or to keep the flow within the inner loop for as long as possible until it reaches the outer loop of recycling. And so we can see here the basic principles of sharing, and so this is talking really about the sort of car sharing, Airbnb, sharing products, which is really about making more efficiency from that particular product. There is then reuse or redistribute, passing things on if they're no longer used. Then we move into the next loop of refurbish and remanufacture before we get to recycle, which is the outer loop. And so this is a concept which is really gathering pace. There are some key principles that I've outlined here on the right hand side of the slide. That is keeping materials in use for as long as possible, designing out waste in pollution. Basically, we don't want to put new inputs into the system which may compromise either the service life or the recyclability at the end of the life. And using waste as resources, this so-called industrial symbiosis, where an open loop in another industry is the material from that loop is taken into a circular system elsewhere. And so being able to use waste as resources within the circular economy is also a very important factor. And so if we think about asphalt, then the principles actually fit quite well. We know that asphalt has a very long and proud history of recycling, but if we look at the asphalt cycle, as is on the screen here, we can see that there is already some focus on either closing, slowing, or narrowing the loops. And so just starting off, and we could start anywhere, but starting off here with this first point here, when it comes to the design of the materials, are we designing the materials to optimize and promote longevity, the efficiency of those materials? How thick does a pavement need to be? How efficient is that material going to be over its lifetime? Importantly, that we don't put any substances of concern into the material at that design stage. When we come around the cycle here, we will say minimizing energy and resources when we have to put inputs into the loop, using lower carbon materials, closing loops. I think it's very well trodden ground for the asphalt industry, the bitumen industry, using RAP from old pavements, helping close other loops from secondary materials. The road industry has a proud record again of looking at end-of-use tires. There's been an awful lot of recent interest in the end-of-use plastics, but this minimizing of energy and resources is a very key way of narrowing that loop, removing the primary inputs or reducing the primary inputs to the loop. At the installation side, we can reduce the energy, switch to low carbon fuels during the installation, during transport, during construction, and then rather crucially here, this longer service life, effective maintenance to extend that pavement life, preservation techniques, the things that can keep the material in service for as long as possible to slow the loop. And this is very important, because every time we go around the cycle, we incur the new materials required, the new energy required, the activity goes around the cycle again, creating more potential environmental impacts and costs. And so clearly slowing the loop, as well as using waste as resources, closing and narrowing the loop through material efficiency is very vital. And then as we come round again, we take the old road, and then we recycle that back into mixed designs and technologies that optimize that pavement. And so, there's a very good fit between the asphalt pavement and the circular economy. You could argue that thus far, the majority of the focus would be on the end of life scenarios and the record of recycling, which is fine. And the high use of RAP is one of the key elements that defines the asphalt industry. However, I believe that as time progresses, there will be more focus on longevity, more focus on effective maintenance, and industrial symbiosis, where we are looking in a more positive manner to introducing materials from other industries to help close other loops. So if we come to bitumen, what can the role of bitumen be in the circular economy? And I've just given a few examples of the sort of things that we're looking at in Shell and how to do this. And so when we come to material inputs, minimizing that impact, we can look to using lower embodied CO2 materials for bitumen. And so we could look at using materials that are either from the biodomain or materials that have are a waste from another industry, for example. So we can look to lower those embodied inputs, as well as any progression in efficiencies in refining and crude oil extraction. We can look to minimize the inputs into the system. We can slow the loop by having longer service life materials, and I'm going to give an example of that later. But moving beyond polymer modification, if we look at polymer modification as the state of the art still today for extending the life of a pavement, we have to look beyond that. We have to say, this is a valuable material that's going to be in service for a very long time, could be decades in the future. We need to make sure that that material has as longer life as possible. So there's a need for development to go beyond the PMB story. Closing the loop, the provision of soft binders for rejuvenating type materials for recycling, optimizing the performance for mixtures containing RAP, very important role that bitumen can play there. And then closing other open loops, taking renewable materials and waste from other industries in order to A, close the loop, and B, minimize the material impacts, is a way in which bitumen can play a role in the circular economy. And then finally, narrowing the loop. So by narrowing the loop, we're talking about less materials performing the same function. So having high performance materials and designs, which means that we get the same function, we get the same ability to carry loads and traffic, but with less materials. Narrowing the loop is also a way in which the binders in particular can play a role. I'm going to share a couple of examples now. One example here of closing the loop. And so quite recently, in the last few weeks, we have now started our first trials of a additive which is based on a waste plastic as a raw material. This material is converted into an additive which can be used to lower production temperatures. So it's a kind of warm mix additive, but instead of being based on a primary additive, if we call it that, it's based on a secondary additive which has been manufactured with waste plastic as a raw material. This product is being trialled currently upon the Live Labs project, which is a Department for Transport project up in the UK, Cumbria, and then their partner Hanson. And so we've demonstrated that this product can produce asphalt with lower mixing temperatures and lower compaction temperatures, as well as having the benefit of being derived from a waste plastic feedstock. And so this is a way for closing the loop. I think everybody's aware that waste plastic is a significant challenge for the world, particularly around single-use plastics and keeping those plastics in the value chain. We see converting these plastics into additives that have a valuable function within the bitumen. So in this case, to lower temperature is an important step in the circular economy. And so I'm going to move on to a second example. So the second example of slowing the loop, this is a technology that we've worked on in Shell now for several years, but we've made our first trials on the major highway network of Highways England with tarmac earlier this year. Pavements age, and the pavements age with exposure to air and exposure to water. And as the pavement ages, it becomes embrittled, and eventually that will lead to some fretting or raveling or eventual cracking. And over the last 5 years or so, we've been working on a way of slowing down the aging of bitumen. So we're trying to go beyond the story of PMB. So we're saying, how can we preserve those PMB characteristics that give that performance benefit for the maximum time in order to actually slow that loop and make sure that the cycle of events in the asphalt cycle is slower. How we're doing that is we have an additive package that we put into any grade of bitumen that we make, and this additive package works in different ways to slow down the aging. And so we think that this has an excellent potential to increase the lifespan of a road. Of course, it's very, very difficult to say in years, months and days how long that's going to last. But we've now got our first trials that we will continue to monitor. We have further trials this year, not just in the UK, but we have trials that are penciled in for other parts of the world, where we're going to continue to gather data to back up our laboratory data, which suggests that this could have a very important impact in terms of pavement life. And so, just to conclude, to take two views of the asphalt, bitumen and paving world, we have a decarbonisation view of the world, and that decarbonisation view of the world is already quite well understood. I think that it's fairly clear what needs to be done in terms of switching fuels at burners, moving the material, using more efficient transport or with cleaner fuels, changing the binders to bitumens with a lower embodied carbon are probably the three most significant levers, alongside other levers like incremental changes in fuel, etc. However, if we turn our attention then to the circular economy, the two are obviously closely linked in terms of the circular economy's ability to reduce CO2 and other environmental burdens. It has a very strong natural fit with asphalt pavements. It's very, very clear that the recyclability of asphalt, the need to prolong life through longer lasting materials, as well as increased maintenance and more care for our roads in general, is going to very much slow down the loop, and it's going to make that more efficient, and in essence it's going to also help on the decarbonisation. Asphalt's got an awesome record in terms of recycling at the end of life, and it's approximating a closed loop system. There's still some losses from that system, but in general, asphalt pavements are considered to be highly circular. However, there's still areas of improvement, particularly in narrowing loops through the efficiency of the materials that we put onto our roads. There are minimizing the system inputs by taking materials from other industries and closing those loops in order to take the raw materials from primary raw materials to a lower level in the system. And as I've said, and then there's a need to slow those loops through increasing maintenance, through extending the pavement life, through longer lasting materials. And so everyone will end the presentation by saying you need a holistic approach, but in the case of the circular economy for asphalt pavements, it's absolutely true that there is interconnected parts here in the circular economy. So the decisions that you make at the design stage will influence the longevity of the pavement. The decisions you make in terms of maintenance will also then, of course, have a knock-on effect on the speed at which the cycle repeats. And so it really is important to look at all of the parts of the circular economy for asphalt holistically in order to make the right decisions to take full advantage. And with that, I'd like to thank you for your attention. I'm going to be here in a few moments to answer any questions in the Q&A, and I very much look forward to hearing from you. Thank you. So thank you for the presentation. I think we have a very short Q&A. I've got the questions coming through to me on a chat box here. I've got a first question. I'm not sure if I'll read the names of the people who've asked the question. I'll leave them out just in case. The first question that's come in is, will secondary materials such as rubber or plastics lead to a risk for introduction of substances of concern for future recycling? So I can start with that one. I encourage you to send any questions as well if you're watching now live. Well, substances of concern has a very technical definition, the first thing I would say, but clearly we don't want to put anything into the asphalt pavement that can pose a foreseeable future risk to either the environment, health, or indeed future recycling. I think it's quite a common consideration. Rubber and plastics as materials in roads. They're added at quite modest quantities, I would say. from a personal perspective, looking at recycling from both my days in the asphalt company and now, I'm not sure that the things that are added to asphalt currently, such as polymers, rubbers, and the new introduction of some plastics into some asphalts, does pose a particular problem for recycling. But I think the question is sent in the right spirit, in that we do have to be very, very careful not to introduce anything that may cause an issue for the future. I'm basing that on evidence of trials where modified materials have been recycled successfully. At the moment, there are no other questions coming in. I don't know if anyone wants to type something in the box. Okay, so thank you. There's another question that's come in here. Yeah, a very pertinent, very good question. How many road authorities are budgeting in a way that will allow them to pay for superior materials that deliver longevity? I think, yeah, I mean, it was fairly central to the circular economy part of the presentation that there has to be a whole life view. I think a lot of us that have been around in the industry a while are familiar with whole life costing as a concept, but it's very, very clear that when we talk about carbon, there is a parallel world here, and that the carbon involved in every time we go around that cycle is quite significant. If you consider the transportation of raw materials, the reheating of materials, the movement of the old road back to the plant, in fact. And so I think that gradually over time there will be a growing awareness of the carbon burden of this, and that really if the world is serious about the reductions in carbon, these are the kind of dilemmas and situations that are going to have to be faced. To provide the lowest carbon upfront material versus the lowest whole life, I think is going to become a debate that is very, very similar to the whole life costing debate that we have in the financial world. I think to directly answer the question, there are not many road authorities currently that budget in a way that budget in a way that allows for whole life costing or whole life carbon. Quite frankly, I think that there's still quite a focus on upfront costs for obvious reasons, but I do think that there's an emerging, a genuine emerging recognition of the link between longevity, pavement life, and the carbon world. I have a question here that says, do we see an appetite for new solutions or testing the new solutions in other regions? I think that Europe in many ways leads the way, and if we look across Europe, there's also a varied picture there. I mean, normally you could consider Scandinavian countries, the Netherlands, UK, France, as probably being at the leading edge of sort of carbon accounting and calculators. Apologies if there's other countries that are also advanced that I'm not so familiar with. I think that once you move outside of Europe, I think that there is some interest. I've personally been involved in some of the sort of city states and authorities in the Far East. So I think there's some interest in the likes of Singapore, Hong Kong, Thailand for these kind of initiatives. I think that when you start with the interest, and we start with a sort of an interest in measuring this. But I think that when we really get down to the business of decarbonisation, there's a need really for clear rules and a clear way of making comparisons between choices. And I think that at the moment, the Netherlands probably provides the best example of that in Europe. I've got quite a few questions that have come flooded in now, so I'm going to have to go a little bit quicker. So we have a question here that says, is there a kind of risk assessment that can be used before using secondary materials for recycling? I think another good question. I think that for sure there has to be. I'm aware of the recent work that's been done by Eurobitume UK in screening secondary materials for inclusion in asphalt. If we go back a little bit in time, there was the Samaris project looking at arisings from roads. So I would say it's absolutely is absolutely necessary to have that risk assessment. I think that it's necessary to check the environmental aspects of the material that's going to be added to the pavement, as well as any other sort of health and exposure related aspects. And so absolutely, there are risk assessments out there. Again, I don't think it's very coordinated across Europe, but there are risk assessment schemes for secondary materials. Indeed, Eurobitume have recently put together a kind of secondary materials position paper. And I've got 3 or 4 more questions here. Let me just take them in the order that they arrive. So, is H2S emissions a topic? Well, H2S is not obviously related to decarbonisation. Clearly, it's an issue because H2S is a gas that presents a hazard, and so again, there are additives that can be used to scavenge H2S. Again, then you have to be careful with the H2S question. You can scavenge H2S, but then it has the ability to regenerate in some cases when the scavenger is spent. And so I think it is a topic. I think there are ways to deal with H2S. It's not really related to decarbonisation, and so I'm not going to go into any more detail in this session. Now I have a question that says, from a sustainability point of view, do you think that a practical approach could be to support a larger use of polymer modification and wax addition for asphalt in every road? And that is a good question. That's something that we are working on, trying to understand longevity and pavement modelling in a lot more detail. I think we understand it fairly well, but I think it's an area that we need to continue to focus upon. I think the big question there, as well as every road, is whether we should see the modification moving to the bases of the road, and whether there are significant carbon reductions for longer life bases, as well as the predominant use of polymer modification in the surface. I think there's a kind of a growing recognition that prolonging the life of the surface is an important and a major part of the story. But however, you can't keep prolonging the life of the surface. It doesn't really make sense to put a very long life surface on top of a potentially compromised base. And so I think there may be some attention towards polymer modification of lower layers, or even indeed the whole pavement eventually. Has any work been done to show comparisons for a typical road section using these principles demonstrating CO2 reduction? We've done quite a lot of work internally in Shell. We've done quite a lot of modelling there. Can I give some estimates? I mean, the CO2 part of the story is rather easy to model. The difficult part of the story to model is the differences in longevity between different materials. Clearly, there's a lot of variables in terms of environment, traffic loading, the pavement existing condition, particularly where there's maintenance and you're putting a perhaps high performance solution on top of an existing road. I'm happy if the person who asked the question wants to contact me. I'll be happy to have that kind of conversation. I can't really give a range of estimates here without really stating all the assumptions behind the model. Then I've got a question around, let's see if I've got any other similar questions. I don't know if somebody from the organisers can give me a time check so that I can just, I've got about 7, okay, sorry, 1 minute. Please finish the meeting. Okay, I've got the names of the people who sent me the questions, so I'm happy if you would like to contact me, or I can answer your questions by email, but I think we need to wrap it up there. So thank you for your time. I hope you found that interesting, and enjoy the rest of the conference.